right, so this video is 4.4D. Ran over, of course. So today we're doing the mean value theorem for integrals, or what we're continuing with, because we just did 4.4C. And this is really connected to the other one, because there's really just one extra step from the average value function. What they're saying is that if you have a function, and we remember the mean value theorem for derivatives, hopefully. If you have a function that looks like this, right, and if you have a secant line, the slope, algebra 1 slope, which is y2 minus y1, x2 minus x, that's how you find that. There's going to be a place where your derivative is the same of that, so this is f prime of c. So what that's happening is that those are equal. So the mean value theorem for integrals is similar, but it's not this. It's similar, but now we're talking about area instead of slope. So if you have a continuous function, there's going to be a number where this happens. So let's just talk about this for a second. It's a little confusing. What I would do is I would take this b, well, actually I guess what you would say is area equals, right? So this is the area. What is b minus a from the previous video? That's the width of the region, okay? And then this is a height, some height. Height at c, right? So what they're saying is there's actually an x value. C is an x value. So there's actually an x value that makes the average height happen. That's all they're saying. So what I would do is I would take this and rearrange it into what we're used to understanding. I would take area divided by width is equal to height. So in other words, what I would say is this is how I would write it. The integral from a to b of the function divided by the width, which is b minus a. And then I would take that answer, which is exactly what you did on the previous example. That is exactly what you did in the previous example. And I would set it back equal to the function and find some value. Okay, so we want to find c. So I would set it back equal to the original function, and then I would find the x value where that's happening. So what is it? Basically, the average value of a function is a y, and the c is an x. That's really all it is. So we're just finding an x value for that previous. So what am I trying to say? At the end of the day, what we're really just trying to do is we're looking at the average height of that function, which is right about here, right? And all we're looking to do is find this point, which is a c. It's an x value. This right here. Okay? So instead of finding the y, which is the red horizontal line, we're trying to find the green vertical, the green value for x. Okay, so in other words, just do the whole entire thing that you were doing before, right? Here it is again. Just do the whole entire thing that you were doing before. I'd like you to copy this drawing down. You can kind of see here, we have that red overestimate here, so this is too much. And then we have a missing part over here, so that's too little. But if you look at those two spots I'm pointing to, those two triangle-shaped things, they kind of cancel each other out. So the average value of my function is whatever this height is. So let's say, for example, it's a height of, I don't know, 7. Okay. Well, what we're looking to do is find the c value, whatever this x is. So that might be x equals, I don't know, in this case it kind of looks like x equals 5 or something like that. We're just trying to find that value. So do exactly what you did in the last problem. Okay? All you need to do is find the average value of a function and then find the x for the function that makes that happen. Not as hard as it actually sounds. Okay, so we need to have the area divided by the width. The area of the region, okay, which is this, from 0 to 2, divided by the width, and the width of that region is 2. So the width is equal to 2. Right? Width. Okay, so that's all we need to do. We just need to solve that. So that's going to give us the average value of our function. So I'm going to start with the blue part right here. I'm going to start with this, and we'll work on that. So I have x squared over 2 minus, now this is a little bit tricky, we got to figure out what this is. It's minus 2x to the 1/2 So we have that minus 2x to the 3 halves divided by 3 halves. But divided by 3 halves is to multiply by 2/3. So I'm not going to do that. Let's simplify that before we put our bar in. So we have x squared over 2 minus 4/3 x to the 3 halves evaluated from 0 to 2. Okay. So working on this now. Do not forget about this divide by 2. Do not forget about this divide by 2 at the end. You got to carry it the whole time if you're going to forget. That's the only downside of my way of thinking, is that you can forget that divide at the end. Okay, so working on the blue integral here, or we'll just do it in black box. We have 4 over 2 minus 4/3. And then we have, this is actually always, just as a rule of thumb, is 2√2. So 3 halves is always just going to be x to the 3 halves. In other words, x to the 3 halves is equal to x root x. This is a kind of cool way to think. So maybe just look at this. This is cool, I would say, helpful. So it's x to the 3 halves is x root x, so 2 to the 3 halves is 2√2. Okay, subtract. The second part has to be subtracted. And that's going to be, in this case, it does become 0 over 2 minus 4/3 times 0. So this whole thing does become 0 in this case. Don't get too comfortable just getting rid of this when you see a 0 here. It's a common mistake. You got to plug that in either way, because sometimes it doesn't come out to 0 even if you're plugging in 0. All right, so what do we get? Well, we basically just have 2 minus 8 over 3 root 2. That is really the value we're looking for. I don't love it because of just how it looks, but this is the average value of the function. Average value of f of x on 0 to 2. So we have basically just done the problem we did on the previous page. But what we want to do is do the mean value for this. So what we need to do is set this right here. We need to set this, whatever this is, 2 minus 8 over 3 root 2. We need to set that equal, oh shoot, look at what I forgot to do. I forgot to divide by 2. Very common mistake, right? So I said it like 2 minutes ago. Don't forget to divide by that 2. So this has to be divided by 2. So if I did divide this by 2, I could actually just divide this by 2 and this by 2, and that would be 1 here, 4 here. Now I divided it. Now I have the average value. Okay, so let's just redo that. So we want the average value of the function. We want to set that equal to the function. What was the original function? It was this right here, x minus 2 root x. So what you're doing is kind of like the mean value theorem, x minus 2 root x. You're setting them equal to each other and finding x now. Okay, so how could we do it? Well, I would say, let's see. I've got 3 over 3. I've got 3 over 3 minus 4 root 2 over 3 equal to x minus 2 root x. Okay, I'm trying to keep solving that. Unfortunately, I think the answer's down here. Try not to give that away. Okay. So I have 3 minus 4 root 2 over 3, or I can just multiply that 3 over if that's okay. Might help a little bit. So multiply the other side by 3 equals 3x minus 6 root x. Okay. I'm not seeing a great way of solving this aside from using a calculator. So I'm going to go ahead and say it's okay to use a calculator. So let's just make sure we're okay with finding this on a calculator, just in case. Just a quick recap. As long as we have time. If we don't, I'm just going to have to skip and see what we got here. Oops. Yeah, so real quickly, this on the graphing calculator, how do we do it? So, oops, okay, unfortunate. So how do we type this in on the calculator? So how do you solve that equation on the calculator, just in case you can't remember? What I want you to do is I want you to take this red equation right here, I'm going to put it in a blue box, okay? Maybe we can just ignore everything else. Let's see if I can find a way to do that. Well, there's your answer, unfortunately. Okay, so we're just going to type this into the calculator. How do we do it? Well, what I do is I set it equal to 0. So what I would do here is instead of just using this, I would set this whole thing to 0. So I'd have 3x minus 6 root x minus 3 plus 4 root 2 equals 0. So that's the equation. And what I would do is I would plug this into my calculator and find the 0 of it. That's how I would do it. 3x minus 6 root x minus 3 plus 4 square root of 2. Okay, I think I've done a decent job with that. It doesn't really seem to like it, but we'll see. So I'm just going to zoom out a normal window, see if it crafts. Perfect. So how do we solve it? Well, we just want to find the zeros of that. So you go to second calc, or second trace, you find the 0. So I'm going to go ahead and bring this window a little bit bigger now. And we just go ahead and find left bound, right bound. So 0.45 repeating is the first one. Do that again. So 0.45 repeating. Let's try to remember that. 0.45 repeating. And 1.79. So hopefully, we get 0.45 repeating and 1.79. So here's what I've got. It looks pretty close, but, and this is definitely okay. This one looks similar. I think it could be something about how we solve it. But I would trust that as be okay, an okay number. So that's how you do it. That's how you find the mean value theorem for integrals. So remember this, if you don't remember anything else, it's the exact same thing you're doing for the average value of function, and then you're taking one extra step, setting it back to the function, and finding the x. And that's all you have to do. Okay, make sure you try those problems that are given to you. I don't have them on this slide here, but they're there. So make sure you try the problems, and we'll talk soon.